introduced the patent. So this graph shows after a given number of years, what's the probability that they had introduced the patent into the market. And if you compare countries that had strong and long patent protection, it was much more likely that they'd introduce things after any given amount of time than after in countries with short or weak patent protection. Okay, so a fundamental trade-off of incentives, a fundamental trade-off in intellectual property is between the incentives for people to innovate in the first place and the distortions that are caused ex post. The more intellectual property protection you give, the more dead weight loss is created. The more intellectual, but on the other hand, the more intellectual property you give, the more you encourage innovation, which is beneficial, right? And the thing to note is that if we have a demand curve like this and there's no cost, as we start to elevate the price above zero, we get quite a bit of profits and a very small amount of dead weight loss. As we elevate the price more, the rate at which dead weight loss accumulates grows relative to the rate at which profit accumulates. And at some point, the profit doesn't increase at all, and the dead weight loss increases by a lot. So what that says is that if we have a trade-off between trying to give profits to the firms so that they'll innovate, and on the other hand, trying to reduce the dead weight loss, we're never going to want to have full patent protection because that will cause a lot of dead weight loss on the margin relative to the profits that it adds. But we're never going to have none because we could get a lot of profits for only a little bit of dead weight loss. Okay. So optimal intellectual property protection will always be partial. And the question is, how strong should that intellectual property protection be? So when we trade off costs versus benefits here, Jacob, what are the costs that we're trading off?
In protection?
Yeah.
Well, the benefit you're getting is that more people will be innovating.
Yeah.
So you get the consumer surplus and the producer surplus generated
Yep.
in the future
Yep.
discounting to them.
Yeah.
But you're losing one that some people won't innovate off the existing products.
Yeah.
And then you're also losing the dead weight loss we're trying.
Yeah, absolutely. That's right. Okay, so let's focus on just the trade-off of the distortion to consumption versus the incentive effect. And to do that, let's imagine that each new innovation creates a market for some new product, and that the products that are created have no marginal cost of production. This is pretty reasonable for many intellectual goods which are nearly free to copy. So let's imagine that all products have the same demand function that are created, Q of P. Let's normalize this so that the quantity that you sell at the efficient price 0 is 1, and that the optimal price is 1. That's just a normalization. Then the consumer surplus is, as usual, given by the integral of the quantity. And the firm earns profits, which are price times quantity, right? Now, I'm going to assume that innovations are costly to produce. And Clémence, could you give some examples of how innovations are costly to produce? Yeah. That's right. And one thing that makes them particularly costly is that most ideas that you start working on don't work out. And so the amount of effort you need to put in to get one that actually works out is usually much higher than the cost of any idea that ends up working out itself was, right? So in other words, if you get one good idea, probably the cost of that was the cost of working on 100 bad ideas to get that one good idea, right? The supply, is going to lead to the supply of innovations being an increasing function of the amount of profit that you expect to make on any given innovation, right? Okay. There's David. Is David Wang here? No. Does anyone else want to try to say what total welfare is, how we could write that down in this situation? Consumer plus producer surplus? Well, there's sort of a trick we can do. So notice that the benefit consumers get is the number of innovations that get created times their consumer surplus, which depends on price. And the number of innovations that are created depends on the profit, which depends on price, right? But, well, then we also have the benefit that producers get. But the producers have to pay the cost to innovate, but then they also get some benefit from the profits that they make. And a simple way to capture both of those things is just to take the producer surplus, which is the integral of the supply function from the profits being equal to 0 to the profits being equal to pi of p, the profits that they make at the equilibrium price p. Okay, so let's now take a first order condition by taking the derivative with respect to p. Does anyone want to try to do that on the board? Jacob?
Can you
Go
put
for
up
it.
the slide with the,
Yeah.
yeah, so I don't remember the
Yeah.
So you're gonna take, so it's gonna be,
Yeah. Nice. And now you got to bring in Leibniz.
that's the tricky part. That was the trick with the extensive and intensive market.
Yeah, so what are you going to do here? Well, the thing on the inside doesn't have any direct dependence on price.
So it's going to be, so it's going to, is it going to be plus S of the derivative of?
It's S of this thing at that point.
Of that,
Multiplied by the derivative of this thing. Right,
yeah.
so it's the rate at which the boundary changes multiplied by the function evaluated at the boundary.
Mm-hmm. And that's because we won't care about the lower bound because it doesn't depend on
Yeah,
price.
exactly.
So it's S of. What's that?
Yep, very nice, very nice. Okay, so there's what Jacob just wrote out. So let's rearrange this. Ryan, do you want to try rearranging this in some way to get it to be a little bit more meaningful? Yeah, so, well, I'll just forget about it. It's not worth it. Okay, so if we just drop the arguments, right, and we rearrange this, we get that pi prime times s prime times cs is equal to negative s times cs prime plus pi prime. Okay.
What do you mean drop the arguments?
That means just drop all the things that are inside here so we don't have a bunch of stuff cluttering up the board. Okay, so let's define the deadweight loss as it's correctly defined to be the consumer surplus that you would get if there was price of 0, because if there's price of 0, all social value would just be consumer surplus because the marginal cost is constant, minus the total social surplus, consumer surplus plus profits at price P, right? So this is the loss because of the price being elevated, right? Then the derivative of deadweight loss with respect to price is negative CS prime minus pi prime, right? So that's just this term over here, right? Okay. So given that, Charlie, can you see how we can do something nice with this? Maybe turn this into like some elasticities or something like that.
So we'll be finding S over S prime.
Yeah. So you're going to divide by S, right? So you get S prime over S.
And then so on the other side, that's
What's this thing?
that's the deadweight loss.
Deadweight loss prime,
Yeah.
right? Yeah.
And then divide that by I prime CS.
Yeah, that sounds nice. And then maybe we can multiply both sides by something. If we multiply both sides by price, then this becomes the elasticity of, or sorry, by profits, by pi. This becomes the elasticity of supply,
Okay.
right? So we get, just out of that, elasticity of supply times the ratio of consumer surplus to profits is equal to the derivative of deadweight loss over the derivative of consumer surplus. Is that, no, this isn't derivative of consumer surplus here. This is derivative of profit, sorry. That should be pi prime there. Okay, so this is the crucial formula. The optimal level of intellectual property sets the elasticity of innovation supply multiplied by the ratio of consumer surplus to profits to the ratio of the marginal deadweight loss to the marginal profits. Okay. So, what are each of these terms? Well, the elasticity of supply, innovation supply is how responsive are innovations to rewards. This is this market maker externality as a ratio, right? It's saying how much value do you create for consumers for every dollar that you get? And over here, we have the marginal deadweight loss we have to accept in order to give one more unit of incentives, right? So this is like the trade-off, the efficiency loss for every unit of incentives we give. Okay. So, Jackson, what does this say determines the optimal level of intellectual property? When will intellectual property be greater?
So you're going to want more intellectual property when either that externality to reward ratio is high or the elasticity of innovation supply is high?
Absolutely.
So yeah, whenever either profit to low or consumer surplus is high or
Yeah,
supply.
absolutely. And you're going to want less if you have to have more deadweight loss in order to get a little bit more profit. So if the elasticity of innovation supply is greater, the externalities, or it's less costly to reward. Okay. To try to, and just to sort of explain some of these things a little bit,